Greetings to you, class. This is Mr. Skanyika with organic chemistry, and specifically today we are going to look at isomers. Isomers are simply compounds having the same molecular formula but having different structural formula. In short, the compounds which have the same chemical formula, we may say molecular formula or chemical formula, but different structural formula. So for example, we are going to look at the isomers of pentane. So we're going to look at the isomers of pentane. Pentane is the fifth alkane, and this is the formula of pentane, the formula of pentane, which is a saturated hydrocarbon. I know that we learned how to come up with the molecular formula using the general formula of alkane. That's why I've not wasted some time on the same. So we know how to write this. So let's going straight now. We also know how to write a structural formula. This is the normal structure formula of pentane. It has got how many carbons? 1, 2, 3, 4, 5. They are all connected in a straight chain. Well, now when we talk about isomer, that's a normal structure, but we're going to write isomer number 1. We see how we can come up with the structure. So I'll put carbons. I can put 4 carbons. Instead of putting the other on that side so that it can be 5, I can decide to make some kind of a branch. It's fine even if it goes up or down. Then I'll place my hydrogens. I'll put my hydrogens on all the sides so that all the carbons will have the hydrogens attached. Okay, so that's how it is going to appear. The normal pentane will appear like this: 1, 2, 3, 4, 5 carbons attached in the same chain. But when we want to write an isomer, you just write it in an abnormal way. You don't write all the carbons in the same chain, but instead you write carbon 1, 2, 3, 4, then we put a carbon. Don't just make a corner and you say 1, 2, maybe you say right at this and you say you are making an isomer, or like this, and you put hydrogens. These are still connected in the same chain. You're not making any isomer. So the isomer, you are supposed to make sure that there is a branch, like in this case. Okay, so let's come up with another isomer. Isomer number 2, you may decide simply to write, so let me just put 3 carbons, and then we put the other one down and the other one up like this. There's still 5. 1, 2, 3, 4, 5 carbons. Then put hydrogens everywhere. Attach hydrogens to each carbon. Okay, you write patiently like that. Then the other carbon this side, it will have the hydrogens like this. Okay, so we have our first carbon: 1, 2, 3, 4, 5. Yes, the normal carbon had all the carbons connected in the straight chain. The other, now this is the isomer which we wrote. We wrote 1, 2, 3, 4. We just made a branch. We can make the branch either up or down. It can even be put on this carbon. Now here we put the 3 here, 1, 2, 3. Then we put the branches up and down. That is fine. That is still going to be called an isomer. So in short, when a question says, can you draw maybe 2 structural isomers of pentane? You can first write the normal structure, the way it's supposed to be written, and then write its isomer that way, and this is the other one. So we have written 2 structural isomers of pentane. Thank you so much for watching this video. We just want to look forward to naming now these isomers. For now, goodbye.